Good afternoon.
Zero minus 5.
You keep quiet. Anything you do, they're going to minus
Mr. Daniel, you tell them.
Okay. Okay, now some of the rules you have to follow. Number one, your appearance is key. Number two, we have 3 judges here. Mr. Laingada will be working on your content, the content of what you are saying. He's a physicist or person too, and a mathematician. So he's a physicist and a mathematician. So he knows what you are saying. So you cannot say, you cannot just tell us anything that is not in relation to physics. So then Mr. Olusegun is also here, and is going to be the one to check your grammatical expressions, the way you are able to express yourself using English language, which is the official language. And also we have Miss Akonde. So she will be handling the area of your PowerPoint presentation. So if you have a very shabby work, don't worry, she's going to award you mark for your shabby work. And if you have a very nice job, well presented, the animations are on point, she will give you the mark that you merit. So please, when you come here, you are only using 5 minutes to run through whatever slide you are displaying. So that means you must have a mastery of what you are doing. So we just need you to show us what you are doing, explain. You don't need to say too much story. So you have your slide, use your slide to explain. We are not saying you should not make use of your slide. You have the laser pointer here. The laser pointer is okay. Let me remove this so you can see. So this is the laser pointer. Everyone of you, so you can use this to show the judges that okay, this is what you are trying to talk about. Use your laser pointer, make use of it, so to explain maybe the particular area you are dealing with. So, and I think we can start now. So over to you, Anthony.
So today we'll be talking about elasticity and Hooke's law. What is elasticity? Elasticity is the property of materials to regain their original sizes and shapes after the force causing deformation is removed. Like a spring, when a material is attached to it. When a material is attached to it, it stretches. The stretch is causing it to deform. But when the material has been removed, it regains its original size. Elastic materials are materials that regain their original sizes and shapes after the force causing the deformation is removed. Examples of elastic materials are spring, steel, concrete, wood, etc. Modulus of elasticity. If a material obeys Hooke's law, stress equals to modulus of elasticity, X strain. Modulus of strain, where modulus of elasticity is a general constant with units n by m squared. The type of modulus of elasticity depends on the type of stress applied. For tensile or compressive stress, the constant is called Young modulus of elasticity. Young modulus. It is used to describe the length, elasticity of a material. Young modulus is defined as the ratio of tensile stress to tensile strain. Young modulus equals to tensile strain over tensile strain. Tensile stress over tensile strain. This is the formula to calculate it. Diagram for elasticity. So this is where the stress is. This is the linear, and this is the strain. This is the diagram for elasticity. Stress. Stress is defined as a force acting perpendicular per unit cross-sectional surface area. Stress is equal to force over area of surface on which it acts. Stress is a measure of the strength of the force causing deformation. Stress could be tensile stress or compressive stress. Strain. This is defined as the change in length per unit length of a material. In other words, strain is the fractional deformation or change in size resulting from stress. It is the ratio of extension of a material to its original length. Formula for strain equals to change in length over original length. Strain is tensile if the stress causing the strain is tensile stress. Compressive strain results from the application of compressive stress. Introduction to Hooke's law. Robert Hooke, born July 18, 1635 to March 3, 1703, was an English physicist who discovered the law of elasticity known as Hooke's law and did research in a remarkable variety of fields. In 1655, Hooke was employed by Robert Boyle to construct the Boylan air pump. 5 years later, Hooke discovered his Ito law of elasticity, which states that the stretching of a solid body, metal, would be proportional to the force applied.
Thank you. Just go through the other slides. Let's see what you have there. Saleh? Is that all? Yeah. Okay, thank you. Any questions?
Okay. Salute your job. You really put something down. But from your first slide, can you go back to the first slide? Yes, I picked up something that you gave us as examples of elastic materials. You said concrete. Is concrete elastic? Where's the How about wood? Wood, elastic. And steel is steel elastic. Okay. All right. In practical sense, we all believe that rubbers are elastic. Okay. Yes, rubbers are elastic, but because of its expansion, which are visible to everyone, we believe that rubbers are elastic. But still, there is more elastic than rubber. Why? Yes, the resistance of steel to a chain makes it to be more elastic. When there is a compression on steel, steel is able to resist it, to impede any form of deformation. So it's able to sustain the external pressure. That's why steel is often used in your springs. You get it? As we have in vehicles, where you see that some vehicles are called the quotations on some vehicles, they give some 2 tons, 3 tons, they mark some 10 tons. That's according to the power of that spring. What the spring can accommodate comfortably. Okay, so concrete steel is elastic, but concrete don't expand. Instead, they crack and they get deformed. So in your rock, concrete have no bearing. Wood also don't expand. So spring, yes. Steel, yes. Concrete, you should have put rubber there instead. And when we look at the tensile strength versus we look at the strength versus the stress, you see that if you stress wood too much, wood will break. If the strain on concrete is overbearing, you see the concrete cracking. So that's why the two of the examples, the last two should be removed.
Okay.
All other things are good. Thank you.
Okay, next person.
Okay, there's something I want to say. There are a few observations that I made when you do your presentation. First is that please, for the purpose of those that are coming after me, please, there's not like fantasy when you're doing presentation. It is believed that you should make your presentation simplified to your audience. It is believed that the audience don't know anything. Is that correct now? So you need to make it simplified. Alright? And so something like EG, do not say EG, you say for example. You may have EG over there, but when you do your presentation, don't say EG, you say for example. IE, you say that is, are you getting what I'm saying right now? It's very important. And also, you pronounce TENSILE as tensile. The word is tensile, you can see. Tensile, not tensile. Alright? And there's not like original, not original. Alright? Then you said remarkable. The word is remarkable, not remarkable. But I'm obviously said, and also, yeah, like I said, you need to pass your presentation. Is it not your own idea? Or is it another person's idea? It's your idea, right? So this you need to personalize it. There's something like for instance, when you were reading a particular definition, you said this is defined. It is your idea. It is defined. The mastery of the presentation. Not this is defined. It means you are reading from it. It is defined. It is personalized like it belongs to you. Are you getting what I'm saying right now? So that is it. And I'm obviously say I love the way you pronounce spring. You did not say spring. You pronounce as spring. That was a nice one.
Okay.
For me, Mr. Ono Anthony, how many days were you giving to do this presentation?
How many days?
Were you asked to prepare for it before coming down here?
So before the
That means you have a week and 2 days to prepare for this. Yes, right? Okay. See, when you come to presentation, it's from known to unknown. You're talking about elasticity. I'm expecting to see something from you as an example. Rubber is what everybody knows. I expect you to do like this, to come with something to show us. Then you move to the unknown, which I don't know. Do you understand? And you're teaching me physics for the first time. I'm already getting bored about it. If you ask me one thing now, like you said, so you see that it's not easy for your teacher to come to class to break it down for you. See, when you're coming for presentation, it's not how much you can type on your slides. It's how much you can give to your audience. Do you understand what I'm saying? Are you listening here? Yes. You will still come out to do the same. Now, you are supposed to make it simplified. And more of pictures, less of what? Less of words. For your slides to look beautiful. When you go back to watch this video, you will not like what you see. I bet you. Mr. Daniel, please play in the video so that you will see how you are done. And I'm very sure you don't like it at all. So you're supposed to give us small words, more pictures. Your font should be the same. If you want to highlight the keywords, highlight it. If you want to use colors that are not color blinded. In the sense that there's some color that will look the same for somebody that has color blindness. Are you there? Arrange your words. And when you get to take your slides to book floor, what do you call the grammar again? It's there. This one, in fact, is a total turn off to me. I'm sure you copied it directly from Google, bam, and paste it here. There's nothing you can tell me. From the beginning of your slides, I know it's bam, bam, bam. And you people are very advanced in technology. You have AI that can break down everything for you to smaller and simplified form that you come down to the class and should have read, digest, think of ideas of how to make this simple. You are doing calculation with your mouth. I've never heard of that before. Imagine Mr. Olayinka standing in class and telling you that 2 raised to power 16 equals to n raised to power 4 equals to 12 equals to 13. The answer is 24. You'll be looking like it. You don't do that. Are you with me? The little calculation you want to do, and one thing you are not conscious of the time. You are supposed to break down your content. Introduction, then you summarize. You didn't have time to summarize because this thing is too lengthy. Are you with me? So after this thing, watch the video again so that you can sink it the next time you're coming for presentation. You will know your strength, you know your weaknesses. But up to this day, we have done very, very well. Round of applause.
Okay, thank you. Next person. Hello. Over to you.
My wonderful judges and audience, good afternoon. My name is Farida Adibalogun, and I'm here to talk about the topic density, relative density of trust and academic principles. Density is a quantity in physics in the aspect of mechanics. It shows the relationship between mass and volume. Density, the SI unit of mass is kilogram and the SI unit of volume is meter cube. Now, for instance, if I want to find the density of a box and the mass is given to me as 10 and the volume is given to me as 5, density is equal to mass over volume. So I'll do 10 divided by 2, which should give me 5. So the density of the box is 5. So we have you can measure the density of a solid and density of a liquid. I'm just going to talk to you about density of a solid and not elaborate too much. I have 10 more time. So a solid can be divided into two: a regular solid and a irregular solid. A regular solid is a solid that has like a specific shape, like a cone, a cylinder, and an irregular solid is a solid that doesn't have a specific shape, like a stone. It does not have a specific shape. Okay, some substances are small, such that their masses and their mass is in gram and their volume is in centimeter. So the density of such materials can be estimated in gram per centimeter cube. Density is influenced by several factors. We have the pressure and volume. It can also be influenced by porosity and purity. Okay, let me talk about purity. The purity of the density of the material can be affected by purity. Like for instance, I have this bottle. Now, when I add, let's say I have sand and I add sand to it, the sand I added to it, like it will not be as pure as it was before. So obviously, yes, it will not be as pure as before. So like obviously the water, something has been added to it, so it's not as pure as before. So it can affect the density of the also the temperature. Now, the temperature of the density of the material can be affected by the temperature. This is when, let's say the density of the material can be affected by temperature. This is when
Alright, Ms. Farida, just calm down. Go over
use your slide.
Calm down.
The density of a material can be affected by the temperature. Like when the temperature increases, when the temperature increases, density can reduce. Yes. Oxygen. So for the porosity of your substance can affect the relative density. Like what you can see it. For example, if a liquid, like what I said before, like now again, porous materials can affect the relative density of a liquid, because porous materials they have porous materials like rocks. They have like a little air. But it's not like an air bag, like an air pocket which reduces the overall density of the.
1 more minute.
Yes, measurement of relative density. We can use a hydrometer to measure the relative density. A hydrometer is used to measure the relative density of liquid. A hydrometer is a glass bottle used to measure the relative density of liquid and solid. That's different to a hydrometer and a hydrometer. Because a hydrometer is used for only liquid and a hydrometer is used for liquid and solid. Now, you can also use gravimetric method. The gravimetric method is the most accurate method of using what? Like, people prefer to use other methods because it consumes a lot of time. So when you get the mass and the volume, you divide it together to get your density, like the density of.
Okay. 20 seconds left.
Upwards is a force which pushes upward. Upwards is a force which pushes upward on a substance.
Okay, thank you, Ms. Farida. Our time is up.
Thank you.
Please show us the other slides. Let's see what you have in the other
This is
slides.
the option, this is the low and high. The high is like the down part and the low is like the top part. Then academic principle. Then there's a Archimedes principle. There's a formula. There's a formula for it.
Thank you, thank you. Questions from the judges?
Yes, I tried to understand. Yes, it is right there. Thank you for your presentation. Yes, I could understand that these are minors in the field of physical sciences. And good job done by Mr. Daniel. John Weldon. Yes, from the inception, you did not, you didn't give us what density is all about. Density, it could be out with foam and stone or magnet or rocks, and give us a comparison. Foam of the same size, rock of the same size, stone of the same size, bring them together and pass them around. Let us feel them. They are the same size, but they don't have the same mass. They don't have the same weight, obviously. Another way is bring out Honor. Honor, please come out. And push him up, please come out. Yes, they are invariably same height, but they don't have the same content inside of them. So honor is dense. He's less dense. He's denser. He's less dense. So when we talk about density, we are talking about what is stopped. Okay, so that's what density is all about. Okay, you said rock is porous.
We can go back.
Yes.
Rock is not porous. What we call anything where water can percolate and pass through, that's porous. Water don't pass through rocks. Rocks can contain water for eons of years. Okay? So when we are going through this right on the rock is denser than most of the material that we have. And it didn't take us through the applications. What's the essence of the density? Why are we studying density? Why? It's not about the math, it's about the applications. For example, what I'm wearing is rubber. Why am I wearing rubber? Why is rubber lightweight? Why is it preferred in some situations? Why are metals preferred in some situations? Why do we prefer leather in some situations? We need to let us know the materials. Anyway, you are welcome to physics. So when next you are doing this kind of project work, we are more interested in your applications more than the theoretical work. Thank you. Good job. Please, I got up.
Because of your presentation, you seem unstable.
At all. Very anxious.
You seem unstable. Just like the old world has my shoulders. Right? Like I had a lot of weight on shoulders, really weak. It's very important that you work with that. When you do presentation, like I said, you are the captain of that session. Alright? We are just here to listen to you. Alright? So that's and it's high time students did away with linguistic maladies. The instance of shady. That's why most times I do correct you people, because I know that to bring it to the fore like this, shady,
Fillers.
something like that, you need to take care of them. Because I could hear you saying all the time. You need to work on that. Farida, please stop pronouncing T-E-M-P-E-R-A-T-U-R-E as temperature. It is temperature. It ends with the schwa sound. And there is not like method. The word is method, not method. Method. The TH is. So that's correct now. It's called delta fricative sound. It's method, not method. Alright? So that is it. And I was expecting you, any presentation always starts with introduction, body, and conclusion. Many of you, it's been about 2 people that have come up here to do their presentation. None of you did any justification to the conclusion. Alright? Please, we're going to be frowning at that. When you come here, we need conclusion. Conclusion simply means your recommendation, your suggestion. Is it clear right now? What you have been able to learn from that you want us to know about? What is your personal, conclusion? That's what you want to know here. So that's it. Thanks a lot.
Okay.
Father Balogun, as Mr. Shaka said, you are too anxious. I don't know why you're too anxious. And for presentation, I don't know, if people are not, your slides are not looking good at all. If I'm scoring little less than 1, or the 2 of you that was, the words are too much. Small words, pictures. You mentioned hydrometer, I don't find the picture there. Is that there's no picture on the internet? We are talking about rock. We don't have live objects. You need to show us. Instead of making the slides too bulky, smaller words are very important so that you can quickly go through it. And when you want to do presentation, some of you don't sit down yourself and read, practice it, understand it before coming out to talk about it. So next time you are coming out, when you watch the video again yourself, you see the way it goes. So next when you are coming out, you need to sit down, digest it. How do I present this to the audience to make them wow, to make them appreciate the stress I'm going through? A week and 2 days is enough for you to make this thing very simple. Very, very simple. Watch videos on YouTube instead of playing games, which some people are doing now, and they are coming down to come and present. Watch videos on YouTube. Understand how they've talked about this density, apart from the way Mr. Daniel has taught you that you don't understand. Watch a lot of videos. Look at the examples they use. Then you bring it. And your colors, I've said it again. The colors are not good. Be very careful with your attestments when it comes to presentation. Use beautiful colors. Use simpler colors. Don't just match colors together like no. It's very, very important because when you watch the video, you look at your slide, you see how it is. Are we on the same page? Yeah. But all to the same, your voice is okay, your pitch is okay. And when you are coming here, those of you that are coming here, introduction, your body, and conclusion. If you don't conclude, you are scoring 0. Apart from all these 2, they are spent. Any other person, you are scoring 0. You are scoring 0. And when you are coming out, be calm. I know it's not easy to come out to talk. I'm sitting there, I can judge you people. When I'm there, I can also make the same thing. But when you are coming out, make sure you are calm. And don't use filler like you have said. Please be conscious of that. Okay? Alright.
Okay,
When
next
you're
person.
your act is well placed. A round of applause for her.
So we'll be having Adenola. Please, Adenola. Yes, we want to start taking your 10 and your 11 so that they can learn from them.
Hey, wow, Mr. Chen, I've been sitting down here. I'm not sure that the ones attentive. No, nothing on the table. You'll be scanning 1-1.
You can start.
Panel of judges, accurate timekeeper, and my fellow students, good afternoon. My name is Adenola Adesonya, and I'm here to talk about the topic projectile and SHM. Simple harmonic motion. First of all, I want to talk about what is a projectile. A projectile is any object thrown into space upon which Okay, as I was saying, a projectile is any object thrown into space upon which any acting force, the only acting force is gravity. The primary force acting on a projectile is gravity. This does not mean that there are no other forces acting upon the projectile, but they are negligent compared to gravity. Some examples of a projectile is a ball being thrown, a javelin or a spear also being thrown. Next up is projectile motion. Projectile motion is a form of motion where an object moves in a parabolic path. The path followed by the object is called its trajectory. Projectile motion refers to the movement of an object thrown or projected into the air and influenced by gravity. It moves in a curved path under the influence of two independent and perpendicular motions, horizontal and vertical motion. Here is a pictorial representation of this. Here we have our projectile being thrown. This is our starting height, the angle at which it is being thrown, and the range in which it is being thrown. The force acting around it is obviously the force of gravity. There is a drag once a projectile is thrown. As you can see through this arrow showing where the drag lies. I have some video clips about projectile motion, but I don't think I have time to take them right now. So let's move on. An example how to use projectiles in calculations. This question is gotten from 2015 WIEC physics theory. A body is projected at an angle 30 degrees. Our angle is 30 degrees to the horizontal with a velocity of 150 meters per second. Our u, as you can see here, is the initial velocity, which is 150 meters per second. Calculate the time it takes to reach the greatest height, and then you take your g, your gravity as 10. From our given data, as I said before, u equals to 150 meters per second, and our angle is 30 degrees. The formula for time of flight is 2u sine theta over g. So we have our 2, and our u, as I said before, is the initial velocity, which is 150 meters per second. Then we use our sine 30 over our gravity, which is 10, and the answer is 15 seconds. Now for the time taken to reach maximum height, the formula we use is u sine theta divided by gravity, which is 150 times sine 30 divided by 10, which is 7.5 seconds. Another example is taken from 2018 WIEC physics theory. A missile is projected so as to obtain its maximum range. Calculate the maximum height attained if the initial velocity of the projectile is 200 meters per second, and take our gravity as 10 meters per second. The formula for maximum height is u 2 sine 2 over theta times 2. Our u, as the question said, is 200 meters per second, and our theta is 45 degrees. So as we implement these figures into the formula, it's going to be 200 sine 45 divided by 20, which will give you 999.8 meters, or 1,100 bm. Moving on, in a projectile motion, there are two simultaneous independent rectilinear motions.
1 more minute.
Along the x-axis, let's move on. You know all these stems from the calculation that I just explained. So we're moving to SHM. What is simple harmonic motion? A simple harmonic motion, or SHM, is defined as a motion in which the restoring force is directly proportional to the displacement of the body for its mean position. Formula for simple harmonic motion is given by A bracket C equals to R W squared times 2, where W is the angular velocity of the particles. So differences between periodic oscillation and simple harmonic motion. Periodic motion, a motion repeats itself after an equal interval of time. For example, uniform circular motion. Simple harmonic motion, it is a special case of oscillation along with a straight line between the two external points. The path of SHM is constraint. I would say more points, but my time is limited. So moving on. So types of simple harmonic motion. The SHM or simple harmonic motion can be classified into two types: linear SHM, angular SHM, and linear simple harmonic motion.
Thank you.
A round of applause for Adinola. It is good.
Mr. Adinola, this is the first time of beginning this presentation.
No, so you're scoring
Okay. Because you still failed to
Oh, I mean, yes.
it's your first time.
Yes.
This is your first time Daniel to be presentation.
You never had
Presentation with Daniel before.
I've done pictures and
So that's not the PowerPoint. Not PowerPoint, yes. This is your first time to do PowerPoint presentation.
yes. PowerPoint is actually about graphics, about what we can see.
Yeah, visualization and pictures.
Colors, images, that's all we want to
Fonts,
see.
everything.
Most people don't care what you want to see, but they
You
just
see this thing,
don't see.
but the font.
Pictures, they speak a lot, they go a long way in impressions. There was a time in the United States, America, sorry to delve into what you said into it. When the Democratic Republic, Democratic candidates found out they are not going to win these elections, and it was just the advent of TVs, color TV. They did a nice imaging of the candidates. They gave them the colors of the United States flag. And that was what they won them the election. That this is the national view, this is someone that represents the United States. Now talking about projectiles, simple application. Will you not give us what the application of this projectile is what you throw up and what comes down. When you throw something up, there is a force behind it. Okay? Which means the higher the force, the higher the height goes. Now, there are some forces that are acting against what's going on. Something like air drag, something like gravity. Right? Now, if you are not throwing vertically up, then we can throw at an angle. Okay? Isn't it? That's what we look at. So, now if you are throwing, are we just throwing for throwing sake? No. There's a target. There's a distance we want to cover. If the distance is going to be long, we want the maximum distance, then we throw at what angle? Tell me. You want a longer distance to be covered. Or the longest possible distance. No, that's what
12 degrees.
That's the range. Okay. If you are looking at the horizontal distance, that's 90 degrees. Okay. These are the points we want to tell us. Now, the other one, simple harmonic motion, SHS. What does it mean in layman's language? Tell us. Yes. Oh, okay. That's just vibrations, up and down movements, or oscillating movements. For example, what are the applications of those things? For example, now, in your elasticity, the going back and coming back to the original form of an object, what are the things we must look at? We must look at the materials, the tensile strength, as I said, tensile strength of that material. Now, what are the applications? Like your windmill, you can use your windmill to provide electricity. And that's an application of simple harmonic motion. Oscillation. Okay? Another one, everybody uses gen. You don't put generator on concrete. Why? These vibrations of that gen will break the concrete. So what do? You pad it. You pad the gen. And when you pad it, it will be able to be stable. There won't be vibrations on the concrete. It won't So what we do is we put something like tires or something that will not make sense, physically vibrating. Okay, so a vibrating engine also is a simple harmonic motion, up and down. That's simple harmonic motion, going from one point, coming back to the other. Like our fan also is going through a simple harmonic motion. It's simple rotation, going back and forth, up and down. So that's it. Good job. Next time, give us more questions. Please.
Before the videos or make up the long pictures, it was like when we did the video for us, and it was too long, so it was 5 minutes.
All right, thank you. Good job.
Adenola, please listen. It's very important that you make your presentation subliminal. Just like I said, simplify it. There are two meanings to words. A word that has denotative meaning and connotative meaning. Denotative means surface meaning, connotative meaning deeper meaning. Is that correct? Like Mr. Olayinka said, simple harmonic motion simply means vibration. Do you understand? Alright, you need to make it subliminal, right? Because of people like us that are evaluating you, but that are not really grounded in physics. You need to break it down for us. That's what presentation is all about. And also, is whenever you're having an informal discussion, you can use like, I was like, you know what I'm talking about. When it comes to presentation, this is formal, all right? You don't use like, I was like. When you discuss with your friend, you do that. When it comes to presentation, it's very important that you do that. And I love the fact that you use a lot of transitional devices. One of them is moving on, all right? I really appreciate that. When you said it, I was flabbergasted because it's very important. It shows the stage at which you are at the point in time you're presentation.
Okay, next person.
Before you go, I
fact, I'm tired of telling you that your slides are not looking fine. You're not looking like the way you are looking. Let me say that in English. No, and your fonts are too small. They are too small. Even if it is his first time you are doing presentation, PowerPoint presentation, I'm sure you have somebody at home that knows this thing in the office, your aunts, your sister, your mommy, your daddy. Don't sit and say, "Daddy, can you help me look at this?" I think it is better. Because when you sit down and watch the video, so you can do better. Well, thank you so much for engaging us. And for the videos, there are videos that can be 1 minute and they will explain what you want to show us about. Can you imagine? You should have played that one for us and we would have been happy. There are videos that are 1 minute, there are videos that are 30 seconds that you just need to explain a point. Okay, now. Thank you.
Okay. Next person, Wisdom. The 10. Hello, can you come forward and control your... Okay. Okay, start.
Judges and my fellow citizens, good afternoon. My name is Wisdom Chukwuemeka and I'm here to talk about work, energy, work, and power. First, I'll be talking about energy. Energy is a thing that pervades all transfer of science. It is a phenomenon. It's linked a wide range of phenomena and enables us to explain them. It exists in different forms, and when something happens, it's likely to be due to energy being transferred from one form to another. Energy transfer is needed to enable people, computers, machines, and other devices to work and to enable processes and changes to occur. For example, in the figure, the water sphere can only be pulled along by the boat if there is energy in its engine from the burning petrol to its rotating propellers. I'll talk about the forms of energy. I'll talk about chemical energy. Chemical energy, food and fuel, like oil, gas, and coal, are concentrated storage of chemical energy. The energy of food is released by chemical reactions in our body. Like food, like wood, gas, and coal, they fuel fire for it to burn. And like for food for human beings, you need it for you to have energy in your body. If you don't have energy, you will not be able to do any other, you cannot do most things, and you might probably faint. I'll now talk about potential energy. This is the energy of the body. This is the energy of the body has become of. This is the energy of the body at rest. In the picture, you see a boy who has, this is a transfer from chemical energy to potential energy. In the picture, this boy uses the food he has eaten, that chemical energy from his muscles, which he uses to strain the catapult and then he uses the potential energy from the strain of the catapult. That is the energy transfer. Kinetic energy. Kinetic energy is the energy of any body in motion. Like as in a hammer, you drive in a nail into a piece of wood. There is a transfer of energy from the kinetic energy of the moving hammer to the other forms of energy. Electrical energy. Electrical energy is produced by energy transfer at power stations and in batteries. It is the commonest form of energy. So it is the most common form of energy used in homes and industry because it's easy for transmission and it's also easier for you to transfer from other forms of energy.
1 minute more.
I'll conclude with heat energy. Heat energy is in all transfers of energy, heat energy is the end of every transfer of energy. It's also the final state of any transfer of energy. No matter what energy it is, it will always end in heat energy. This is where I will conclude my talk on energy.
Are there other slides?
Yes.
Show us other slides. So you didn't talk about all this power and the rest. Okay, thank you so much. Okay.
Master Wisdom, have you eaten? You've eaten? You've eaten? You don't show that you've eaten. Why did I ask you that? I asked you why. Why did I ask that question? Because you presented energy without energy. Your presentation was energetic. Okay? And you told us that food contains chemicals that are made up of chemical energy, which I believe the energy should be used. Yeah, good presentation, but you did not illustrate it. So can you illustrate work and force? Just show it work and force.
If I should move something from one place to another, we can apply force, energy, that is work. Why? If I should, there are also different types of force. But if I should move this thing from one destination to another, by any means, it's force. Like this marker. If I move it from here to here, I'm applying force to it for it to move in a specific distance. And doing that, I'm doing work.
So what is force?
Okay.
Thank you. Force is a push or a pull, or anything that moves something or tends to move. If I ask you to keep pushing this wall to eternity, the wall will move. You know why? It's not. No, the wall can move, of course, but you don't have the required force to move this wall. But you are applying force. But if you should push this table now, let's assume you have the required force and it moves, work is done. Force applied without any movement, without any motion, that's ordinary force. But once there's a displacement, then work is done. Good job.
Okay.
Wisdom, why did you keep pronouncing kinetic as kinetic? Kept hearing kinetic. It needs to work. Okay, it's kinetic.
Okay. Thank you. Please, I will quickly use this to explain something to all of you. Please take notes. Now, I want to present his work. I don't need to be reading everything that is here. Most of you are just busy reading. Now, okay, look at it. You are supposed to have read all this. So you are just coming here to tell us a short or a summary of everything you have written down. Okay, from power now. I already know what power is. Power is what? The rate of doing work. Then you move to the slide that explains that. Can you see the? You can analyze this way. Okay, power is equals to what? Work done over time taken or energy transfer over time taken. You move to the next slide. You don't need to explain some of these things. The unit of power, as you can see, is what? The watts, and it's the rate of working 1 joule per second. So you just move fast because some of you are just busy reading. You are looking at the what do you call this? The laptop screen. So then like this person now, his slide is delaying. That's a lot of delay before it plays. So you have to take care of that. Then you just solve question. Okay. Let me see. You don't have a very good, and your animation takes time. Now you already have energy in different forms. You have what? Kinetic and potential. Explain it. You don't need to be reading it here. Reading it here is taking your time because you have so many points at the end, but you don't get them because you are busy reading stories. Please, the next set of people that will be doing this, plan work on that. Yes, the next person, please.
Yes, but those of you that are coming, please go and change your colors before coming to this. I'm not joking.
Your colors are very bad.
Like wisdom, I could not see the top, I could not see the subheading. Why? Change the colors before you come here. Because we will score 1. I'm not joking. Let me see one good slide for use as an example today.
That's it.
Okay.
My name is Ayo Jolua Motiwa, and I will be talking on equilibrium of forces. Good afternoon.
You can move to this side. This moves that to your.
First of all, I would like to mention what equilibrium is. Equilibrium is the state of a body at rest or moving with uniform velocity under the influence of several forces without accelerating. There are 2 types of equilibrium. That is static equilibrium and dynamic or kinetic equilibrium. Static equilibrium, this is when there is no net force. This is when there is no net force acting on the body and the body is at rest. For example, this marker on the table, the body is not under any motion and the net force is 0. How to make the net force is 0? If the force acting downward, that is the weight, and the force acting upward, which is the reaction force, are equal, the net force will be 0 because the second force minus the first force will give you 0. Dynamic or kinetic equilibrium. This is when there is no net force acting on the body and the body is moving with a uniform velocity. An example of that is a constant rotating fan. Since the fan moves at the same speed and it doesn't change, the net force is 0. Resultant and equilibriums. The resultant of two or more forces acting as a point to the same force will produce the same effect both in magnitude and direction as the original force when added together. The equilibrium of two or more forces is a single force which balances and keeps other forces acting on the body in equilibrium. The equilibrium is equal and opposite in direction to the resultant. And this is the result. The principle of triangular forces. This is an example under triangular forces. And the solving is here. Moment of a force. The moment of a force about a point to an axis is the product of the force and the perpendicular distance between that point or the axis. Before rotation and the line of action of the force. Moment is force times perpendicular distance. And moment is a vector with units Newton meters. Principle of moment. If a body in equilibrium under the action of parallel forces is the sum of the clockwise moments, that is, the sum of clockwise moments is equal to the sum of the anti-clockwise moments. Conditions for equilibrium of a number of non-parallel external forces. There are types of equilibrium, that is stable equilibrium, unstable equilibrium, and neutral equilibrium. Stable equilibrium is the type of equilibrium in which an object tends to return to its original position when slightly shifted. An example would be a conical collapse or something. If you slightly displace it, it will return back to the original position because the center of gravity will take it back down. This is a diagram to represent it.
Okay, Master Suwa, do you have the applications of equilibrium? If you have it, let's review it.
I have a diagram representing unstable equilibrium. This occurs when an object tends to move further away from the original position when slightly displaced. If I manage to balance this marker and then I hit it, the marker won't return back to the original position since it undergoes unstable equilibrium. Then neutral equilibrium. This is the type of equilibrium in which an object tends to come to rest in a new position. For example, a ball resting on a smooth surface. If I shift the ball, it will return back to rest in a new position. Like that. Then factors affecting stability. The height of the center of the gravity affects stability. For example, a tall person will be less stable than someone that is not as tall, due to the fact that their center of gravity is higher than that of a short person. And the width or wideness of the base. The wider the object is, the more stable it is. Thank you.
Okay, yes, let me ask you a question. Tell me, why is it that the sports cars that they use in racing, why is it that they have very low in terms of the height from the ground?
One reason is due to the fact that the lower the height, the lower the center of gravity, which makes it more stable. And also, it helps to reduce the friction on the surface of the car.
Okay, so like that.
Yes, sir. Is the F stable?
Yes.
Why is the F stable?
Because it undergoes uniform rotating motion and the speed doesn't change.
Thank you.
I'm seeing a official professor. When you get there, there might be much. You know what? I love the fact that you know how to use transitional devices. Whenever presentation is going on, transitional devices show chronological movement from one point to another, and that you should them, you will soon reach it. You have the wealth of traditional devices. So I was really swept off balance. I really like that. And but when you were doing your presentation, at the introduction, when you were doing greetings, you had mentioned your title, your topic before you did the greetings. What do you say about that? I think greetings should come first, right? You should acknowledge those that are present before you go into the business of the day. So that's just what I can say. By and large, I really enjoyed the presentation.
Okay, Mr. Tuwayojo, your slide is beautiful. I appreciate that. A round of applause for yourself. Shows you really did a very job. And I'm expecting a girl to actually give me one because you know I'm gender biased. So, but apart from the fact that you did very well, I think your pitch of voice is too fast. So in presentation, yes, you need to, when you know that you talk faster, you need to learn to, somebody told me that you chew your word, swallow, maybe swallow, chew, I don't know. Shall understand that grammar. So you make it a bit. Then when it comes to the conclusion, you can increase the weight. Do you understand? Or apart from that, you've done well. So you need to watch the pitch of the words when you're speaking. So a round of applause for yourself. You have done very well. You're welcome.
Good afternoon, my name is Igor and I'm here to present my topic. Name of my topic is self-extension.
You can stay here. You can stay here so I can see what's up. You stay beside your system.
Self-extension can be defined as the force that acts on a liquid surface, which makes the liquid surface to behave like an elastic skin. If you observe when you talk and you close it, the water comes down slowly because of surface tension. The formula for surface tension is 1/2 equals over length. Effects of surface tension. Surface tension makes flotation of objects denser than water or coal when subject is non-rotatable and its weight is small enough to be borne by forces arising from surface tension. For example, water striders. If you look at water, there are some insects that are light and they can walk on water because of surface tension. Yeah. The water allows those animals or insects to walk on them because of the use of surface tension. Separation of oil and water is caused by the tension in the surface between these dissimilar liquids. Example of effect of surface tension: water beating on leaf, water strider staying on top of leaf because of surface tension, and water beating on cloud, as you can see in the example. The molecular explanation of surface tension. Surface tension is due to the intermolecular forces of attraction between the molecules of the liquid. In the body of liquid fluid, the molecules attract themselves uniformly in all directions, making the resultant force on any molecule such as B to 0. But for a molecule such as A, as in as A on the surface or near the surface, when molecules from the body of this liquid put it inward with none of you equally pulling above outward. So,
One more minute.
Reduction of surface tension. Surface tension can be reduced by addition of soap solution of detergents, addition of camphor, addition of alcohol, addition of methylated fluid, increasing temperature of the liquid.
Thank you. Thank you. Oh, this slide, I can't see it, so I'm not interested in looking at it again. Please, okay, sir. Questions? Face your question.
Yes. I found out that each time I boil water, I always have a recipe in my kettle. Why?
When people are in soup or any something, water from steaming, let me explain, water steaming glass. But when you do something like making, it doesn't stay with the same glass. Because I would like to show you because making be very expensive. And as you said that you left it inside your place because of surface tension. Water will not completely come out, not completely drive out of the place. But if you use the
Simply because the water is not energy. It's not pure water. Perhaps I got my water from the well and I have particles in it. So boiling water will make the impurities in it settle. One of the ways of stopping water is by boiling it. You get it? Simple.
Israel, I think you need to work on the use of terminals. When you were talking, you said, my judges, you don't belong to me. And so come on. Sometimes at the assembly I hear my founder. The founder. You know why? Because that is called a definite article. Whenever it is used, it indicates the subject of discussion that is known to the speaker and the listeners. And that's why the is used. Is that clear? So please, for those that are that will still come on board, please, we don't want to hear my listeners, my fans, my judges. No. The judges. Is it clear right now? And the word TMPRATURE, I've corrected about 2 people. The stress on the first syllable, not temperature, it is temperature. The 10 we pronounce louder than the others. And it is not temperature, not chop, but temperature, not temperature, temperature. Alright? So that's it. Yeah.
Okay. Thank you so much, Chaz. We're calling on Mercy.
Facilitators and my colleagues, good afternoon.
Good afternoon.
I'm going to present my topic on electricity, Ohm's law, and resistance connection.
that does not move. It's an electricity that is at rest. Benjamin Franklin in 1706 to 1790 confirmed that there are two types of static electricity, negative and positive. Glass rubber with steel becomes positively charged, and plastic rubber with foil becomes negatively charged.
Use the arrow.
The law of electric charges can be stated that like charges rebel and unlocked charges attract. So now we have conductors and insulators. Conductors are materials that allow free flow of electric charges, e.g. metals. Insulators are materials that do not allow the passing of electric charges, e.g. dry paper, dry wood, rubber, silk, and cotton. So now we have production of charges. We have friction, contact, and electrostatic. Electric current. Electric current is a type of electricity that moves. So, electric current consists of moving electricity charges. When the Van der machine is working, the table tennis ball shown parallel so and so. Like we can see in the diagram, the table tennis ball, and these are the two metal plates. The ball touches each plate, it becomes charged. One metal plate is unlike, one is positive and one is negative. Like I said about the laws of electric charges. Unlike charges attract. So as the ball is moving, and that each one plate, the ball becomes charged. So now we have effect of electric current. So now an electric current has three effects, which revealed in this diagram.
1 more minute.
So now we have heating and lighting, magnetic and chemical. Ampere and coulomb. The unit of current is ampere, which is defined as a magnetic field. 1 ampere is 1,000 of an ampere. 1 milliampere is 1,000 of an ampere. Current is measured by an ammeter. The unit of charge is the coulomb, which is defined as the term of the ampere. So now these are the circuit diagrams. Connecting wire joint, wire crossing, cells, batteries, switch, the ammeter, and your lamp. We have the series and parallel. Series and parallel circuits. In series circuits, in different parts, in series circuits, the circuits are joined together in a straight line. While in parallel circuits, the circuits are opposite each other. So now, in conclusion, static electricity and current electricity. First of all, static electricity is the motion at rest, like I told you guys earlier. And current electricity is the electricity at movement or in motion.
Thank you. Observation.
Yes, electricity is white. Thank you, Ms. Notch. But what exactly is your point? What's your area? In electricity. Currentness. So you tell us the type of current we have. What are the applications? That's what we want to get. So tell us the types of currents that we have. What?
No.
No, you don't have to do that. Currents.
Types of currents.
Yeah. We have two. Direct currents and alternating currents. So examples of direct currents. Batteries. Okay, you know when you join two batteries together, it supplies direct current. So alternating currents. Like generator, main source, and NEPA. Now, if I want my battery to last longer, how do I connect it? To last longer. If I have 3 or 4 batteries and I want it to last longer, how do I connect it?
When you buy like a bag of food, and the bag is fitting your arm, the arm to have.
Okay, thank you.
Thank you.
When you want the battery to last longer, connect them in parallel. But you want it to work faster, you connect them in series. Alright, thank you.
Okay, thank you.
Good job.
Mr. Chair, it was really a nice presentation, but there are some things that outside why we presented. First is, I want to ask you, is electricity countable or uncountable? Electricity, is it countable or uncountable? So why do we use an electricity? Electricity, sometimes we can use an. And also, while we're doing your presentation, I kept hearing comprises does not indicate any preposition. Comprises, then you list what it is. Okay? These comprises is, not comprises more. But you can use consist of. But comprises does not indicate. Thank you.
Okay, for me, I can see you're very well composed while talking, and you're calm. You actually show your level of grasp. And when you want to use your hand, you don't bring your hands down. It shows I'm not confident. You are standing properly, you're using your hand like this, not like this. You are very composed. I love that. I wish I can be like that when I'm talking. But when you want to talk, your hand comes like this. It doesn't go too much. Right. But you know, you need to write it. You don't bring your hands down. It shows I'm not confident. I'm interested. But apart from that, you're very confident. And your slide is going to work better on them. Thank you.
Okay. Thank you. Yes.
Yes, the longer it is.
Oh yeah. Let's clear from. Please be fast. You're using 3 minutes. 3 minutes. Be fast. Start.
My judges and my judges and my wonderful students, good afternoon. My topic for today is electrostatic charges.
Can you please have your seats?
Electrostatic charges is said to be at rest. Benjamin Franklin discovered that there are 2 types of charges. We have negative and positive charges. Negative charges, this is where a charge is using, this is when a charge is collecting electrons, while positive charge is when a charge is using an electron. We have charges, atoms, and electrons. There is evidence that
that you can picture an atom as being made up of small central nucleus containing positively charged particles called protons. This is the diagram explaining this whole thing. Then we have the Golding electroscope. The Golding electroscope, it is used in detecting small atoms. And we have metal rod, insulating cloth, metal plates, Golding and glass window, moving of metal plates ended by resting on rest. Electrodes, insulators, and conductors. In an insulator, electrons are bound firmly to their atoms. In a conductor, such electrons can move freely from atom to atom. While in bright good insulators include plastics such as polyethylene, cellulose, acetate, pencil, and nylon. Examples are wood, paper, cotton, the human body, and the earth. Electrostatic induction. This entails that when a negative charge is close to the metal sphere, the positive charge comes first and the negative charge goes outside to separate because of the positive cross standing sideways. Attraction between uncharged and charged objects. The attraction of an uncharged object by a charged object near it is due to electrostatic induction. A small piece of aluminium foam is attracted to a negatively charged polyethylene rod, hence the movement. The top of the solid near the rod and the bottom, hence the force of attraction between the negative charge on the rod and the positive charge on the top of the rod is greater than the force of the portion between the negative charge on the rod and the negative charge on the bottom of the rod. This is the diagram. A slow stream of water is bent by electrostatic attraction. Then we have dangers of static electricity. When we have lightning, a tall building is protected by a lightning conductor consisting of a thick copper string fixed on the outside of the building, connecting metal spikes at the top to a metal plate in the ground. So this is the diagram of the lightning conductor. Using of static electricity. Fluid ash precipitation. An electrostatic precipitation removes the dust and ash that goes up to the chimney of coal burning power station. It consists of a charged fine wire mesh which gives a similar charge to the rising particles of ash. Photocopier. This contains a charged drum, and when the papers to be copied is placed on the glass plate, the light reflected from the white part of the paper causes the charge to disappear from the corresponding part of the drum opposite. From the graph generator. Demonstration. As you can see in figure 35.9, a spark jump between the dome and the discharging sphere. Electrons flow around a complete path or circuit from the dome. This is the diagram, and this is the air and the green grid. Electric field. When an electric charge is placed near to another electric charge, it experiences a force. This is a uniform electric field. The electric force does not require contact between the two charges, so we can call it an action as a distance force. Moving charges are deflected by an electric field due to the electric force exerted on them. This support will be linked in the inkjet printer. The electric field lines radiating from an insulated positively charged conductor sphere and a point charge as shown in figure 2.
Thank you, Ms. Doris. Observation, sir.
Yes, ma'am. Yes, Ms. Doris. Good presentation that is you have on this. Thank you very much. It brought me back to one of the aspects of realities in physics, static electricity. Yes, what can we do to arrest thunder? Thunder strike, what can we do to arrest it? Or what is thunder strike? Lightning, yes, can it be arrested? Have you experienced it before?
Like lightning or
When it's okay. So
How do you arrest it?
how do you arrest it? You've not experienced it before. Does it shock?
yeah.
It's electrifying, so how do they arrest it?
Like when it's raining every day, you know, like you're not meant to stand on that day because of the high chances of the electric of the lightning affecting you, or stand beside a wet tree, or hold anything that involves iron.
You are inside the house now. And there is
You know, it guns, I've seen where it guns TV and all those things.
okay.
How do we arrest it?
Yes, every house must have a neutral connection. So if you see the top of the house, you will see something like lightning up there. It was connected and it was happened. That is, it was making straight directly to the earth. There was a metal like this that was bound, tied to that, or connected to that neutral wire, and it will be grounded, nailed to the ground. So once there is a discharge of charges up there, the cable up will arrange it and send it to the earth.
She has this in her slide, but she does not know what she was speaking.
So that's the application of everything. Okay. Another time, whenever during hammer time, when you are moving your head, sometimes you hear back, there are sparks there. Why?
Okay, from experiment, I read said that when you hold your hair, the dry cold, dry season, and the dry place, you see the top of the hair on the cold.
Yes.
This is used like static electricity, like an experiment.
Okay, thank you.
What causes this sparks? That's what I was asking you. What?
Okay, nice job. Thank you. All right, you can do it.
Okay.
Okay, after the idea.
Okay, because you have done so well, pretty well compared to especially with your slide. And you've done a very good use of it. That's one thing. You've shown us with your hands direction on the board, pictures, fantastic. Your poise, your presentation, wonderful. But the thing is, the words are too plenty. You should have reduced them. See, when you see you have so much, take it, tell any AI to rewrite it for you, to make it smaller. Then what? You take it to Grammarly, or you take it to, what's it called? No, this rephrase software. Quiboids, you take it there, you rephrase it, you bring it back. That's how to make it smaller. And you've done very, very well, or you can do better. Like a round of applause for us. So far, so good.
Yes.
You have done pretty well. You've made my gender proud.
How was that?
What's the problem? You do what?
Can you say that?
No.
Yes. Okay.
2:30 already. That's one.
Just 2 minutes. Run through everything you want to say.
Good afternoon, teachers, and the audience.
Hello, can you speak?
Today, my topic is on motion, equation of motion, velocity, time graph, displacement diagram, and acceleration.
Mr. Let's take it on Monday. This boy will also do it. I don't know.